This is just a little review on how to do some mole questions. First couple things. First thing, a mole is two things, and that's confusing. Okay, so my two conversions I always use is a mole. I'll do this one. One mole is equal to Avogadro's number of particles. Those could be atoms, could be molecules. For example, a mole of sugar is a mole of molecules, meaning you have a mole of C12, H22O11. You have a mole of those molecules. And each of those molecules has a bunch of atoms in it. So you can have a mole of molecules, or formula units, or you can have a mole of atoms, such as helium, which means you have 6.02 times 10^23 atoms of helium. Now, a mole of this would not have the same mass as a mole of helium. This has got more mass to it, more weight to it than a mole of helium does. Okay, there's more stuff to it. So a mole is a counting unit, but it is not how much a mass is. Okay, 6.02 times 10^23 atoms of helium would have a mass of 4 grams if you look on the periodic table. Okay, 6.02 times 10^23 molecules of sucrose sugar would actually have a mass of 342 grams. Okay, so that's how much a mole of that would weigh, because a mole of it is bigger, has more mass to it. So just a couple questions here to kind of compare those things. First thing, I want to know which of these, which of the following would have more mass. So out of these two, which has more mass? In other words, which has more grams? One second here. So if I'm doing that, these are equal in terms of number of particles. They're both Avogadro's number of particles. They're both a mole of particles. But a mole of boron, if you look on your periodic table, is 10.8 grams. We'll just round that to 11 grams. So that would have a mass of 11 grams. A mole of helium, same number of molecules, or excuse me, same number of particles, same number of atoms, would only have a mass of 4 grams. So this has more mass to it, because each boron is a bigger atom than helium. It's got more protons and neutrons. 2 moles of carbon, so I look up how much a mole of carbon is, and it's 12 grams per mole, so 2 moles of carbon would be 24 grams. This is a mole of magnesium. That many atoms of magnesium would have a mass of 24 grams. Those are equal. They're not equal in terms of number of atoms, but they're equal in terms of mass, because magnesium atoms are about twice the size of carbon atoms, twice as massive as those. So that's one of the things we kind of do. Here's a couple conversions. So I'll do about 3 examples of conversions. One of the things I always tell students, if a problem starts with moles or finishes with moles, it's a one-step problem, meaning I only use this conversion or this conversion. If you're going from grams to atoms, molecules, or particles, it will be a 2-step conversion. If you're going from atoms, molecules, or particles to grams, it will be a 2-step conversion. But if you're starting with moles or finishing with moles, it's a one-step conversion. So number 3 here, as soon as it says how many moles, I know it's going to be a one-step conversion. Are in 500 grams of this. So always start with the number they give you. So this problem, I'll start with 500 grams. This one, you start with 3.5 moles. So we go 500 grams of calcium nitrate. So we're talking about formula units here, or molecules. My rule is nothing goes underneath here. When I get to this spot over here, sorry about the glare right here, I'm going to put grams, because the grams is up here. So my labels have to cancel. I'm always writing the word 1 mole either on top or on bottom. In this case, I'll put the 1 mole on top, because I know I'm going to put grams down here. So for calcium nitrate, I need to add up all the grams of calcium nitrate, which means I have a mole of calcium atoms, which is 40 grams off the periodic table, 2 moles of nitrogen atoms, so nitrogen would be 14 times 2 is 28 grams, and 3 times 2 is 6 moles of oxygen atoms. So for oxygen, 16 is the mass of oxygen per mole, times 6 is 96 grams. So we need to add all those up, which I believe is 164 grams. Labels cancel. Grams and grams. They're on top and bottom. They cancel each other. Okay, I'm sorry, that says 164. You probably can't see it because of the glare. Okay, it's a 164. I'll jot that over here where you can see it. 164 grams. So my labels cancel right there. I know I'm done when I get to the label I want. It wants to know how many moles. I'm done. I don't need to use Avogadro's number because it's not asking about particles or atoms or molecules. So I'm taking 500 and dividing by 164. Again, my labels tell me whether I'm multiplying or dividing by these numbers. Okay. That's approximately 3 moles. Okay, approximately 3 moles. If we pick another one out here, how many molecules, or sometimes I would say particles or formula units, are in 3.5 moles of potassium hydroxide? So start with the number that's given to you, 3.5 moles. On my next step, I always write the word 1 mole either on top or bottom. I'm picking either this conversion in the black or that conversion in the blue. Well, in this case, I'm going to write 1 mole on the bottom because my labels need to cancel. So I have 2 choices to choose from. I either put in the grams from the periodic table, how much a mole of this, what the mass of a mole that is, in grams, or I put in Avogadro's number of representative particles. Well, in this case, it's asking you for molecules, so I'm going to say there's 6.02 times 10 to the 23rd molecules. Moles cancel. It's asking for molecules, so I know I'm done. I know it's only a 1-step problem because we started with moles. Again, if you start with moles or finish with moles, it's a 1-step problem. So I'm taking 3.5 times 6.02 times 10 to the 23rd. I'll let you guys figure out that answer. I'll do one more problem here. Let's say we have, how many atoms are in 400 grams of gold? Let's slide that up a little bit. So I'm going to get the number of atoms in 400 grams of gold. Sorry, I'm going a little bit sideways. So start with the thing that's given to you. I have 400 grams of gold. I want to figure out how many atoms would be in that sample. Your answer in atoms is always going to be large. It's going to be a lot of atoms. So go here. Whatever label's there always comes down here. Figure out where you're writing the 1 mole. In this case, I'm saying I have a mole of gold. I got to figure out how many grams that is. Okay. That is not Avogadro's number. The mass of a mole of gold is off the periodic table. 1 mole of gold is 197 grams. My labels cancel. So if we take this divided by 197, that's how many moles we would have. A little over 2 moles. 400 grams is a little bit over 2 moles. It wants an actual number of atoms, though. So we got another step here. Again, try to figure out where your 1 mole goes. 1 mole is on top here, so I'm going to write the word 1 mole on the bottom. The only other option I have, we only have 2 conversions. We're either doing the molar mass in grams or we're doing Avogadro's number. Well, we've already used the molar mass, so our next one would be 6.02 times 10 to the 23rd atoms. Mole cancels. We're left with atoms on top. That's the label we want, so we know we're done. So we're multiplying 400. We're dividing by 197, and we're multiplying by Avogadro's number. Doesn't matter what order you do that in. You can take 400 times Avogadro's number, divide by 197, but that's what you're going to. Your answer should be in scientific notation. Your answer there is 1.22 times 10 to the 24th atoms. There's a lot of atoms in a 400 gram sample of gold. That's all I got. Good luck.